Hey there! In this video, we will learn about series methods, but more important than knowing different methods is that you understand when to apply them. Let's recap the basic concepts from Pandas. We saw that Pandas library has two main data structures, series and dataFrame, and we could think of a dataFrame as a table and each column of the table as a series. We also saw that a Pandas series has three main components, the index, the values, and the name. And by the way, if you didn't watch the previous tutorial, you might want to do it before watching this one. Now, the most important information from this presentation. It's unlike that we create Pandas series manually. Then you might ask me, how will I use series when working with Pandas library? Well, the most common way is that you read data from a database, Excel file, text file, or whatever the source is, and it become a table or a Pandas data frame. And on this data frame, you want to answer some questions. Let's take this example where we have a data frame about football teams. Let's say I want to know what is the team with maximum offense stats, or what is the team with minimum defense stats, or how many teams are playing a specific league. And note that to answer each of these questions, we need to look at a specific column, right? And a column is nothing but a Pandas series. And it just happens that a Pandas series has plenty of methods and attributes that will help us to answer this sort of questions easily. And this is how you'll be applying series methods in your data analysis. Let's get started. Alright, the first thing you have to do is import all the libraries we're gonna use, in this case Pandas and NumPy. And if you want to have a look at the entire list of methods and attributes of a Pandas series, we can either use the documentation, and here you can see which ones are the attributes and which ones are the methods. And the second way is to use the dir function. How does it work? You create a Pandas series and then you give that or you provide that as an argument of the dir function. If I run it, you're gonna get the entire list of methods and attributes of this object. Then let me just scroll down. You see that it is quite a lot. But in the beginning, there are some which starts with underline, and we actually don't have access to those. Then if I just exclude them and look for the size of this list, we see that we have more than 200 methods and attributes. Will I show you all of them? No, I will not. So I will show you the ones I find important to know, but we also see them during this course. Okay, let's create our first Pandas series. Here I'm using a dictionary to create a Pandas series where the keys are the index and the values are the values of this Pandas series. And as I said, a Pandas series has three main components. The index, in this case A, B, C, D, E, the values of this series which goes from 10 to 50, and the name. The name in this case would be the header of this column, alright? Okay, now how to get each of them? Let's start with name. How to get the name of this series? You only type the series name, then you use the dot notation, so that's how you can access methods and attributes. Now we type name. If I run it, we get series name. Alright. What is it? Is it an attribute or a method? It's easy to know. So in case you don't have the parentheses, that's gonna be an attribute, right? And by the way, the attribute is something which describes this object. Okay, what about the values? How can I get the values? There is one attribute to return the values. In this case, you type dot, then values, and it's going to return a NumPy array. As we saw in the previous video, Pandas is written on top of NumPy array. Alright, but we also have a method for that. How is it called? toNumPy. If I run it, it returns a NumPy array as well. And finally, we have the index. How to get it? You just type the series name, dot, and just to let you know, you can always press tab, and you also have the entire list of methods and attributes, but in this case I want to have index. If you start typing, it's gonna tell you which one starts with E, N, D. Okay, there is only index. Alright, if I run it, we get our index. But look, what if I only want to get the list? Why I'm asking that? Because the index attribute returns an index object, right? We have two ways to do it. The first way is to call the list function, and the second way is to use another method called toList. We again get the same thing. So to get the values, we saw there is the toNumPy method, And to get a list or to convert this object to a list, we have the toList method. Okay, let's start doing something a bit more useful. Let me just print again the series. It is very common that we have to rename our index. And do you remember how can we call the index? Well, it's just dot index, right? And we want to assign a new index to that. If I want to rename the entire index, how many elements do I have there? A, B, C, D, E. It means that I have to provide 5 elements. In this case, I'm going to provide these elements in a list. So Brazil, Germany, France, Belgium, and Chile. All right, look, we didn't get anything, but if I now print this series again, now the index is no longer A, B, C, D, E, but Brazil, Germany, France, Belgium, and Chile. What is also common is that you want to replace only one index or some indices, but not the entire one. For these cases, you want to use the rename method. What you do, you type dot rename, then what you need to provide is actually a dictionary. And you remember what is a dictionary? It is this data structure where you provide the key and the value. In this case, the key is the index you want to replace. Let's say I want to replace Brazil. And the value is the new index. Let's say I want to replace Brazil to England. Okay, let's replace another one. Let's say I want to replace Belgium. And let's provide then USA. Let's run it. Let me just give some space here. All right, if you compare, you see that Brazil became England and Belgium became USA. And now there is something very important to know about pandas. Let me just print this panda series again. What is the name? Is my series. If I run it, now Brazil and Belgium is back. What is going on? A lot of methods from pandas has this feature that you can just type what you want and see what's gonna result, but it actually does not take place in the object, or it does not change the object. And if I want this change to take place, we have to inspect this function, in this case rename, and there is this argument called inPlace, and by default is false. If I now provide inPlace and then give true, we can now print our series, and then we see that this modification changed the object. If you're having any issue to understand this inPlace parameter, let me know in the comment section. But I also need to tell you that when we start talking about dataFrame, we're going to be using that very, very often. Now, let's talk about how to get and set values of a panda series. Let me just make some room here. All right, let's say I want to get the element 10 or the element which has the index England. How to do it? I can either use 0, right? Or I can also write England. England. Okay? And similarly, we can also set values in the same way. Let's say I want to set the value associated to the index England to, let's say, 100. Let's also change USA. USA would be 0, 1, 2, 3. So the index 3. So this would be my series. Then I give now not 0, but 3. Then let me give you 300. And let's also show our series. Okay, I need you to remember that we can either use the index or the label index to get or set a value of a panda series. And this will be the entry point of our next two methods, loc and iloc. You will be using loc and iloc methods to select elements not only in a panda series but also with pandas dataFrame. They are actually pretty important. Then let's learn about them. Let's create our panda series. Now let's select elements of this panda series using the index. And when we want to use index, the method you're going to be using is iloc. Then you type dot iloc, open and close brackets, and now we type the index. Let's take the first number, then I give 0. Cool. What if I want more than one number? Let's take Brazil and Chile. How can you access the last element? It's -1, right? Now, if I want to type more than one element, I need to provide a list. And then I'm gonna get 6 and 10. But pay attention, you are not only getting the value 6 and 10. you are getting a subset of this Pandas series which contains the index, Brazil and Chile, and the values associated with that, 6 and 10. Is it clear? Then let's see if you're paying attention. If I want to get the values 6 and 10, what should I do? What do we have now? We have a Pandas series, right? How to get the values? We can either use the values attribute or the toNumPy method we saw in the beginning of this tutorial. What is it? toNumPy. Yeah. All right, let's come back to iloc. And by the way, how can you memorize that iloc you can select by index? I like to think that loc is location. Then I can locate elements using index. That's the reason why you have the I in the beginning, iloc. Okay, all right, we know how to select one element. We know how to select several elements, but we can also use the range notation. Let's take then the series which contains Brazil up to France. What should I do? Well, Brazil is the first element. If I want to use range, we use the column. What is the index of France? It's 0, 1, 2. And by default, the last element is always excluded. It means that if I run this code, France will not be included. I need to add one unit here. Then let me provide 3. Perfect. Let's do the same using the index label. What is the difference? Now we no longer use the iloc method, but we use the loc method. So you type loc, open and close brackets, and we type the index label. Let's take first Brazil. Brazil. Cool, we get 6. Now let's take Brazil and Chile as we did before. Then let me type Chile. As I have 2 elements, I'm gonna put them inside a list. Nice. And if I want to get the elements in a range, we can also do it. Let me just delete then Chile. We don't need the list. We go from Brazil, column, France. Okay, what is the main difference? Now, when using loc, the start and the end values are always included. If I run this code, we're gonna get the subset of the original Pandas series. And by the look of this output, you know that it's a Pandas series, right? But if you doubt, you can always check. Then you use the type function. It's going to return it's a Pandas series. All right. Now let me tell you something very useful. You can combine the loc method with Boolean filter. I hope you remember what a Boolean filter is. If not, please check the last video. I'll make some room here. I can just type series 1 greater than 7, for instance. If I run it, I get a Pandas series which the values are booleans. And what we saw, and I really hope you remember that, we can use this result to filter a Pandas series. In this case, I'm going to use the same series. And what we get is a Pandas series where the test or the filter returns true. Then we only get France, Belgium, and Chile. That's how we perform Boolean filter. And as I said, we can combine that with loc. We just type .loc. Then let's read this command. We take a Pandas series, which is called series 1, and we're gonna locate all the values where this test returns true. In this case, then we get France, Belgium, and Chile. Let me just run it to show you that it works. And voila. To finish this topic, I want to show you that we can also set values using the loc and iloc methods. Let's print our series method here. Now what I'm gonna do, I'm gonna use loc. Then I want to get the range between Germany and Belgium. How many countries are there? 1, 2, 3. Then I should provide 3 values, right? Let's use 70, 80, and 90. Now, if you print this series, we just set the values from Germany to 70, France to 80, and Belgium 90. You can also provide the numbers as a list. This also works. And we can also use iloc. How to do the same with iloc? What is the index of Germany? Germany 0, 1. Okay. What is the index of Belgium? 0, 1, 2, 3. But we know that this index is excluded, then we should provide 4. If I run it, we get the same. Okay, Loc and iloc methods are very important, and just to let you know, there are also dataFrame methods as well. Then please learn them. Alright, the next two methods I want to show you are count and value counts. For this example, I'm gonna create a Pandas series from a list of 50 elements where the countries Brazil, Germany, France, Belgium, and Chile are picked randomly but with the same probability to be chosen, alright? Let me run that for you. Let's say we want to count. So how many countries are there? In case you want to know how many countries are there, we only need to use the count method. Then you get 50. And if you remember, I created this series using a list and the length of this list was 50. Let me just hide this series. How to do that? Double click this gray box here. Alright, we know that there are 50 countries, but now I want to answer how many times each country appears. And for that, we use the value counts method. And if I execute this cell, now we get that Germany appears 13 times, Brazil 12, France 10, and so on. But I told you that they have the same probability to be chosen, right? Why is this happening? Well, if we increase the number of samples, let's say 500, then let's use again the count method. Okay, we know that there are 500. If I now run this method, the value counts, the numbers now are a bit more even, right? Because the larger the number of samples, the higher is the probability to get the same number of frequencies. Okay, what if you want to normalize this number? Well, if we inspect this function, there is this parameter called normalize. I'm gonna take it, and by default it is set to false, but now I'll set it to true. And what you see is that Chile and Germany represents basically 21% each, Brazil 20%, and France and Belgium around 19%. And if I want to get the number of unique elements of a Pandas series, we use the nunique method. Cool. Out of 500 elements, 5 are uniques. But if you're not only interested to know the number of unique elements but the element itself, you do not use the nunique but the unique method. Let me run it. We're gonna get France, Brazil, Chile, Germany, and Belgium. I just noticed that I messed a bit with my Jupyter notebook. Then let me just put the unique method here. Oh, you're not here. You are actually here. And here you are dot and unique. And I'm doing that because I don't know if you know, I have my GitHub and you can get this notebook there. Right, I will delete this cell, rerun this one, number of uniques, we should get 5. Unique, we should get France, Brazil, Chile, Germany, and Belgium. All right. So I find those methods quite nice and you're gonna be using them with categorical data. Okay, what are the methods again? Count, where? There, count, value counts, and nunique and unique methods. Now let me show you the describe method. This is also a good one to know. Let me just get some space here. Okay, that's good. The describe method, as the name suggests, will describe our data. And the way it's gonna work will depend if our data is categorical or numerical. I'm gonna show you both. Let me just paste one small code here. We are creating a Pandas series containing 3 programming languages, Python, JavaScript, and Julia. And there will be 20 values and they will be selected randomly. Now, I'm gonna show you what we're gonna get when I call the describe method. And what we get is a Pandas series with basic statistics of our Pandas series, like the count, the number of unique elements, what is the most frequent value, in this case JavaScript, and how many times it appears. In case we have numerical data, let me just copy another code here. What's gonna happen if I call the describe method? Describe. We will get the count, in this case 100, the mean value, the standard deviation, the minimum, the maximum, and the percentiles, 25%, 50%, and 75%. You want to use describe method to get a quick overview of your data. And what is good about it is that we can also use it with Pandas dataFrame. And finally, we have the methods which returns the mean, the maximum, the sum, the cumulative sum, the standard deviation, and so on. Let's use this Pandas series as an example. And what to do? You just type the name of your series. In my case, it's called my series. then the dot notation and the method you want to use. Let me also add another one here, which is the standard deviation std, and if I run it, we get everything. Let me show you the cumulative sum. I print the series again, and now I want to get the cumulative sum of this series. We use the dot notation, and you call the method you want to use, cumsum, which stands for cumulative sum. Then you get 10, which is the first element, 10 plus 20, that's going to be the result of the second element, which is 30, and so on. Okay, I have two more methods I want to show you. Sometimes you want to find not only what is the minimum value, but where it occurs, or what is the index where the minimum occurs. And for that, we use the idmin and the idmax methods. Let me just run this code here. Look what we get. This is our series, right? What is the minimum value is 10, and what is the index where it occurs is A. Therefore, we get 10 and A. If you want to get the maximum, we just change that from min to max, and from min to max. And then we can compare again. The maximum is 50 and it occurs in the index E. As I mentioned in the beginning, series has a bunch of methods, and it is not very useful to spend a lot of time show you one by one. I know this video is already quite long, but I really want to show you the methods which I, Rodrigo, find very useful. And to wrap up, I want to answer a question from a subscriber called Guilherme. In the last video, I showed that we can perform math operations between series, and as long as they have the same indices, the operation will happen element-wise as NumPy array does. We can take this yellow series and just make operations with this pink series, right? So 10 plus 30, 20 plus 70, 30 plus 100, and so on. However, in case you want to perform math operations between series with different indices, by default, Pandas will return NaN, which means not a number. And this is gonna happen as soon as it does not find a match index. Now, if you say I want to get series 1 plus series 2, it's gonna say, okay, what is the first index? 0. 0 occurs in both series, then you can do 10 plus 30. And the same happens with the index 1 and 2. Then you're gonna have 10 plus 30, 20 plus 70, 30 plus 100, but now 40 has no matching index, and as a consequence, Pandas will return NaN. And then comes the question from Guilherme. How can we assume that the missing data is 0 and still get a result? I will create both series. Series 1, 10, 20, 30, 40, 50, and series 2, 30, 70, 100. If I do now series 1 plus series 2, as we saw, we're gonna get 40, 90, 130, and NaN. Alright. To solve that, we are going to use another method, and that's called the add method. How to do it? We use the series we want to add to another series. Let's take series 1 dot add, and as argument, you provide the second series. If I run the cell, you're gonna get the same result. But if you inspect this function, there is a parameter called fill value, and by default it's none. If I just assign that to 0, now the missing data will be interpreted as 0, and therefore we get in the index 3 and 4, 40 plus 0, which results in 40, and 50 plus 0, which results in 50. Okay, and I think that will do for this tutorial, and in the next video we'll start talking about Pandas data frame. Then, see you in the next one.